My name is Jeremy Browning. I'm an application expert here at MLC Cam Systems. Basically, what an application expert is just a super nerd. At my last job, I designed machines that made artificial DNA for drug research. Those machines are actually getting put through their paces now. If you're counting children in that picture, that's 3. Yeah, sleep is not a thing, especially when we're all at home. All tensions are high. A little bit about MLC. We're one of the largest VARs in the US, and what I want you to take away from MLC is the fact that we do tech support a little bit differently. So if you've ever called into Comcast or AT&T for tech support, that is tier 1 tech support. We don't do a tier 1. You call in, you're going to get someone like myself on the line, and you're not going to hear me thumbing through the pages and saying, did you reboot your machine? We respect your time. I understand that you might have a very hot question, so we will start answering your question right away. If you're not too familiar with MLC Cam Systems, this is our territory. We do go all the way up into the Pacific Northwest, all the way down into Florida. So every state that you see, we sell either SOLIDWORKS, MasterCam, or 3D printers, and more specifically, the Markforged line of 3D printers. Now, what I want to model today is a speaker. Now, this is a nice screenshot of a speaker, and it's really good to send to maybe prospects or maybe your customer that you're working with. It's very good to send that. But let's model it from scratch. Now, I want to prove to you that this is a real speaker. So here's some pictures of a speaker that we designed here in our Dallas office. So we 3D printed these on some machines. We printed a couple different versions, some carbon fiber ones, some clear ones. And these things actually sound really good. But we had some design challenges along the way, and I want to kind of walk through how to model this speaker and some of the higher end tools in SOLIDWORKS that you could use. So just for your own information, we did run some simulation on this speaker, and you can see at this point we were looking at the airflow through the port tube and how fast that air actually flows through that tube. Another thing we looked at is the speed of the air going around all of the devices inside this speaker. So there's a lot going on inside the speaker. We got to really put our engineering caps on and figure out, are we going to have port noise? There's a bunch of parameters that we had to design around. In this simulation, you'll see that we actually are building a surface anywhere that the air speed is going too fast and it's going to create noise. So one thing that we had to design around was actually having this speaker be between 300 and 350 cubic inches internal volume. So here is a completed design, and you can kind of see this speaker here modeled. This is fully populated, the assembly is complete. But what I'm going to do is I'm going to model this speaker completely from scratch. Everyone on here is a SOLIDWORKS user, and at the end of the day, you're going to have to hit File New at some point and model something from scratch. So no tricks up my sleeve. We're going to model it completely from scratch. So let's do that. I'm going to go. First, I want to point out that there is a front piece and a back piece. They slide together with these lips. You can see that they slide together, and there's 20 thousandths of tolerance, a gap around the sides, so that they actually will fit for sure. So I'm going to close this thing completely. I mean, you can see the SOLIDWORKS 2020 emblem. There is nothing open. So let's hit File New. We're going to choose a part in inches, freedom units. Now, I'm going to talk about good practices as we design this as well. So not only are we going to model it from scratch, we're going to talk about best practices and good things that you should be doing while modeling. One of the things I like to describe that you won't see in any training manual is bulletproof modeling. So everyone on this webinar has probably opened a model that their coworker made a change to. Definitely not you. Definitely their coworker made a change to. And one small change just made the model explode. Well, if you have bulletproof practices, bulletproof modeling skills, that change should not blow everything up. You should be able to go in, make small changes, and your design intent drive the way the model changes. So with that in mind, let's go and let's define some sizes up front. And to do that, I'm going to use equations. Now, if you don't know, there is a search command up in the top right of SOLIDWORKS. So normally it's on help. You can switch it with this little arrow to commands. Looks like the DOS prompt, a little bit outdated, but we all know what that is. And you can type EQU. And you can just click on equations, or you can hit the eyeball, and especially if your coworker is asking you where it is, it'll give you a nice big red arrow and say, here it is, and then you can just walk away in triumph. Well, let's fire off the equations. And the first thing I want to do is I'm going to design this speaker to where we have 4 different values and then a radius. So we're going to have a top and back width for both the top and the bottom, or front and back for both the top and bottom. So first of all, we're going to have a height. So H for height, and that's going to equal 7.5. Now, I've already worked all these dimensions out just so that you guys don't have to see us tweak everything. But one thing that's really good about making equations is you have a one-stop shop to change every single value. Now, you don't have to go into every single sketch and make all these changes. All you have to do is come in here to the equations. So H for height, and then I don't even have to put all of that. I can just put D for depth, and then I can say I want a TF for top front, and top front is going to be 3.25. You guys get to see a typing exercise today. So top front, and then I'm going to have a TB, and that's going to be top back, and that's going to be 2 inches. This is a really good practice. If you've ever opened anyone else's model and you're like, what the heck did they do? This is a really good way to document everything that's going on. I'm going to have another one called BF, and this one's going to be 7.25. And that's going to be bottom front. And then another one called BB, and that's going to be bottom back at 5 inches. All right, and then I'm going to have one more. We're going to call this curves. So we all like nice smooth curves on our models. And that one's going to be equal to 20. All right, now we've got all these dimensions defined already. And once you've defined these equations or these global variables, you can find them under the equations folder with all of their names. Now, you don't have to use just letters. You could use phrases if you wanted to. Obviously, you see that with curves. Now, in SolidWorks, most SolidWorks users, we like to make box. We extrude box. We pull out of page, we make box. It's very easy. We make very orthogonal or geometry shapes, right? But some of the hardest things to do are, in fact, those curved shapes. And if I open this model up again, you'll see that there's a lot of curvature to this model. So you can see it's curving in multiple directions. And so this is some of the things that people get a little timid about. And we need to be able to have all those tools in our tool belt to be able to make shapes that are not just real blocky and me extrude box. So we're going to do that here in this brand new file. Now, I'm going to create a sketch on my top plane. And the first thing I'm going to do is I'm going to use this midpoint line. Now, this midpoint line, this is a really good one, especially if you need symmetric parts to build around your origin. So at that point, I just started with the midpoint line. Now I'm going to use a regular old line. Now this is going to be the depth. Now, in case anybody didn't know, you can click on a line and you can say for construction geometry. You can switch it over to a piece of construction geometry. And then when I draw this other line, I could use a midpoint line, or I can pick up this midpoint reference and make it coincident with the end here, which is perfect. Now I'm going to pick up a 3-point arc here. So 3 clicks is what it takes, said the Cookie Monster. So there we go. We have our original shape. Now I need to define this, because best practice is to always work with fully defined sketches. This is an underdefined sketch, as said in our status bar down here in the bottom, so I do need to define this. So this one is going to be equal. So just like in Excel, when you hit the equal key, that is going to show us everything that we can link this to or start an equation. In this case, I'm going to go to global variables, and that's going to be equal to the bottom front, which is BF. And I can hit my green check, and you'll see that you get a little symbol indicating that it is linked to a variable. I'm going to do the same thing for the backside here. That's going to be equal to the global variable of bottom back, which is BB. I can hit my green check. Notice that I'm not dimensioning. I mean, I'm dimensioning, but I'm just linking it to a value that already exists in this model. Now this is going to be equal to the global variable of curves, nice smooth curves on this speaker. And I'm going to make that one and this one on the other side equal. I like to use my context toolbar. If you're not using it, you probably should. One more thing that we're going to have is this one is going to be equal to a global variable of D for depth, and green check. Now this is completely defined. We have a fully defined sketch as defined in our status bar. So that's the way we want to have our sketches, is completely defined. Now I can get out of this sketch. Now, to make something that is a little more complex, you're not going to, well, you could use an extrude, but we're going to use a little more complex features. You could use either a sweep or a loft. In this case, I'm going to use a loft. But to use a loft, I need another shape to go up to. Well, before I do that, I have to sketch on a plane that's up there. Well, I sketched on my top plane. So what I need is another plane up here. So I'm going to hold control and I'm going to drag up to create an offset plane. Now, ideally, what you would do is hit equal and then link it to a variable, but you can't do that. That's just a SolidWorks thing. So I'm just going to hit my green check. But what you can do is you can link that offset plane depth to a variable, but you have to accept the plane first and then double click on the plane. And then we can double click on that dimension, and then we can link that to a global variable of h, which is height. A quick rebuild here, and you'll see my plane is in the correct place. I can now sketch on said plane, and I can do exactly what I need to do here. So I can draw another line again. Obviously, we could use our midpoint line if you wanted to, or you could pick up that midpoint reference and put it on the origin. And at that point, I need to define the width of this line. And that's going to be equal to the global variable of top front, or TF. All right. Now, the next thing I need to do is do the back. So I'm going to use another line back here. You see we can draw another line. Of course, you can pick up this midpoint relation and hold control and put it exactly where you want. And then we can define that one. Now, I use a lot of mouse gestures, and that's where you right click and you can drag through any one of these commands that you have. If you're 10,000 IQ, you can, not necessarily that I'm that, but I've been asking for a second level for a long time. And I finally got smart one day. And instead of creating a second level on my mouse gestures, I just mouse gestured me hitting my S key. Because hitting your S key, you can then right click and customize the S key. So now just mouse gesture hitting your S key, and then you can find everything right there and customize it all. So just a little tip for you. If you like mouse gestures, then mouse gesture your S key to give you that second level. All right, now I'm going to link this one to the global variable of TB, which is top back. Hit my green check. I need another 3-point arc. So go from here to there and 3 clicks. Said the count. And then I've been watching too much Sesame Street with all this quarantine stuff. So maybe some of you can relate. This is going to be equal to the global variable of curves. And hit my green check. Again, I'm going to link this curve to that curve, making them equal, and then I can get out of this sketch. Now, we have our framework here for our speaker, but I need some nice curves for this to follow. So on my front plane, I'm going to create another sketch that just contains 3-point arcs. So from sketch to sketch, creating like a little wireframe of this speaker. And of course, these are going to link to the global variable of curves. Hit my green check. And again, I'm going to link both of these where they're the same curvature, and then get out of this sketch. Now, there are faster ways to do this, but I'm going to go the most robust modeling way to do this. So I could have used 3D sketches, but I'm going to use 2D sketches in this scenario. Now I'm going to take this front plane because I need to sketch the same thing on the back. I'm just going to create an offset plane by using control drag. But I want this model to always have a plane on the back side back here, so I can link this as an offset plane that pierces that point. So I can then hit my green check. Now, no matter what that depth changes to, this plane will always follow. So then I can open a sketch there and do the exact same things. Get a 3-point arc here, and then link this to the equation or the global variable of curves. And last time, make these equal. and we're good to go. Personally, I like to hide my planes, but you'll see now we have a wireframe of our speaker. Now remember, our design challenge is between 300 and 350 cubic inches for an internal volume. Well, right now we have 0 for internal volume, so we're pretty far away. But what I need to do is go to Features and do a lofted boss base. If I loft from this sketch to that sketch, that is exactly what I need, except you'll see that our curves is going very prismatic up to from point to point. So I want this to follow our curves. To do that, I need to use a guide curve. Now, when I choose a sketch that has 2 open profiles in it, it's going to prompt me to use my selection toolbar. And that's totally fine. We'll select that group, hit my green check. I'm going to do the same thing over here. The same selection toolbar pops up. You'll see what these guide curves do is they pull it out and make it follow that guide curve. So I'm going to do 2 more times. We're going to get back here, use that one, and then finally back here and use that one. Perfect. Now we're following our guide curves, and I can hit my green check. You'll see that we have some nice solid here. It's curved in a couple different directions. But now what I want to do is check the volume. So I'm going to go here to evaluate. I'm going to go to my measure or mass properties. Let's go to mass properties. You'll see my volume is 326 cubic inches. Well, if I was shooting between 300 and 350, I would say that's smack dab in the middle. So I'm going to say that's okay. But this is an internal volume, and this is a solid. So as you can see with our section view, I can prove that this is in fact a solid. So what I need to do now is I need a 1/2 inch wall thickness for my speaker. So what I need to do is create an offset, okay? Now, I can use the feature called shell. Now, you guys are probably very familiar with shell, and it's going to remove an internal volume. Well, there's another feature inside of shell. Well, it is shell. But what you can do is you can say that you want a 1/2 inch wall thickness. And then you can check the option for shell outward. Now I want everyone to pay attention. When I hit my green check, it's going to get a little bit bigger. You see it kind of jump out just a little bit. What it's doing is it's taking the faces that exist and it's offsetting it by whatever value, and that's a 1/2 inch, and then removing the internal volume. So it's like an opposite shell. So now you can see that we have the exact same volume inside that we just had as a solid. So that's a really good technique that you can use to create a cavity inside of a part. So first thing I want to do is I want to check the internal volume and make sure that it is in fact still between 300 and 350. So a tool that I can use to check an internal volume is I can grab a plane that completely intersects that space and also that body, and then I can launch this tool called intersect. Now intersect is one of my favorite tools because now I can create an internal region. When I create these internal regions, you'll see that I don't want to merge the result and I want to hit my green check. Now hitting tab on top of this model, you'll see that I have 2 internal pieces. I can then combine them together. This is like a Boolean addition or subtraction. In this case, I want to add both of these solids. And the reason I have 2 is because it was split down the middle by that right plane. But we were then able to get the internal volume of the overall speaker. So now I can add those together and I can evaluate and mass properties and don't include the hidden bodies because we have that thing hidden. You'll see that I am at the exact same size that I was earlier. So now I can come back and I can delete that body. That way I just have a feature in the tree. We're deleting that combine, and then I can re-show my speaker. And again, this thing is hollow. Now, what I need here is I need to add some fillets. So we need this thing to be nice and rounded. So let's go back up to the fillet command. Now I want to point something out. Everybody uses manual fillet. Well, most people use manual fillet. There is also a fillet expert. And what you can do is you can add multiple sizes of fillets in one go. So I can say that I want a 3/4 inch fillet, and I'm going to add it to all 4 of my external corners, like that. And then I can hit apply. And then I can come back and say, you know what? I want to now add an 1/8 of an inch. And I want this to go all the way around the front and all the way around the back, and then I can hit apply. So notice that with this green check, I added 2 fillets at 2 different sizes in the same command. So that's how you can use the fillet command to add a bunch of different sizes in one go. Now, I have 2 pieces that this is going to have to be. So I'm going to need to cut this, but I'm also going to need to screw them together. So to screw them together, I need some space for my 4 mounting bolts. Now, if I cut this model and section it and accept that section view, I need some material to follow this edge so that we have some meat there so that we can actually put a screw. Now, one thing that we could do is we could just extrude a boss, but I want something a little more sexy, a little more smooth that can follow our speaker contour. Well, what I can do is I can create a sketch on this back face, convert the entities, and then draw a line. So when I convert those entities, it's going to pull all those edges right over there to it, or onto this sketch so that I can use them. Now on this one, I want this to be a specific distance across. So for the back, I want this to be a 1/2 inch wide, and then from point to point, I want that to be a 1/2 inch tall. So a 1/2 by 1/2. Now I have too much here. Now what I can do is I can trim away, I can get rid of all the stuff that I don't need. Now I want to point something out. This is something that a lot of people haven't realized. There are these red dots. And if you go too far and you accidentally cut too much, obviously you can hit Control Z, but if you just keep holding and then you back up through that red dot, you'll see that we can undo the things that we cut. So just keep that one in your back pocket. I can then get out of that sketch, and I'm going to create another sketch up here that converts these entities again, and I'm going to create one down on the bottom. So I'm creating sketches that we can use to loft to create our mounting bosses. So this one, bottom back is going to be 3/4 of an inch wide, a little bit bigger, and then it's going to be 1 inch tall. Now again, I want to make sure that I only have a single closed profile in here, so I can use my trim entities, get rid of all that, and then once it highlights in this blue shaded color, that is SOLIDWORKS telling me that my shaded sketch contours, that is a closed contour. All right, now I can get out of there. I have my 2 sketches in the back, but now I need to sketch in the front. Well, if I hit section again, I need to actually flip the direction that I'm sectioning, and I can then sketch in the front of this thing. So now I can create a sketch on this front face and do basically the same thing, convert the entity, and then draw a line that goes from that edge to this edge, and then give this a height. So from vertex to vertex, that's also going to be 1 inch tall. And then from that vertex to that vertex, that's going to be 3/4 of an inch. Now, this is one of those things that you could also link into your global variables like we talked about in the beginning, or this is something you can do on the fly. Best practices say that you would probably link this into your global variables, and that's okay. It's going to be, just like I talked about earlier, it's going to be a better place to go to one stop and make all of your changes. One more sketch here, convert these entities, draw another line, and then hook this up and make them coincident. And then finally, the top front is going to be 3/4 of an inch tall, and it's going to be 3/4 of an inch wide. Remove all of my extra stuff using our trim command, and I can get out of my sketch. Now I have 4 sketches here, and I can turn my section view off. Now with these sketches, that's exactly what I need to do a loft. So from one profile to another. Now I can go features and I can do a lofted boss base. Now I'm lofting inside this model. So if I loft from there, you see I get my preview and I can hit my green check and it succeeds, but that might not be exactly what we want. And so let's flip this and let's look inside this model. So if we're 3D printing this, this is going to be a huge design challenge. So what we need to do is we need this loft to follow the curvature of the speaker. So to do that, what I can do is I can then go to my original loft and I can show the sketch for the bottom and the top. Now, what we can do is leverage these sketches so that we can use them again. So let's go edit our loft here. And this time I'm going to use a guide curve. But if I choose this, notice that it grabs the entire sketch. That is not what I want. So I'm going to clear that selection. Instead, I'm going to right click and use my selection manager so I can grab just one segment inside that sketch and then hit my green check. You'll see now that if I hit my green check, this loft is drastically different. It follows along the curvature of our speaker. I'm going to do the same thing for this top side, but I'm going to leave it sectioned so you can see it happening. Loft from this shape to this shape, and obviously it goes straight forward. Guide curve, I'm now going to use my selection manager and use this to follow and hit my green check, and then hit my green check to accept it. So you'll see that we have a lot more meat there now, so we can put our mounting bolts. Now, to speed myself up, I should probably do that all over again. I'm just kidding. Please don't, unless you're getting paid by the hour, I guess, don't do that completely all over again. What we can do is we can take both those lofts and the right plane, and we can use the mirror function so that we can mirror them to the other side, creating some symmetry. So perfect. We have sped ourselves up, and we have designed this speaker so that it has a good internal volume. Now, I want to do something really quick. I want to do another intersect to check that. So let's go right plane and this solid, and let's do that intersect command, and we're going to create an internal region and hit my green check. Again, I can hide this, and we can take both of these and we can combine them together. And once you combine them together, that solid and that solid, we can then do that evaluate mass properties. You'll see we're at 317 cubic inches. We're still within spec, so we're good to go. I can just delete both those features, or you can leave them in your tree. It is totally up to you. But now that we're back to looking at our model, and you see it's hollow, what I need to do is cut it in half. So to do that, I'm going to create a sketch on my right plane, and I'm just going to draw a straight line. Now, it's going to be a fully defined straight line, but it's just a straight vertical line. I'm going to start to dimension this thing, and when I dimension this thing, I want this to be equal to the global variable of height times 1.5. So you can even use those global variables in equations to modify those dimensions. Now, I want the front piece to be 1.25 inches back. So this is how big our front and back piece. We're going to create a housing basically, and then a front cover. Now, I also want to define how far from this point to our origin is, and I want that to equal the global variable of height, and then divided by 4. All right, and that puts us in the right spot. So you can see that this is going all the way through our model. Now, one thing that people usually are not utilizing enough is surfacing. And a lot of times you say that word and SOLIDWORKS users will kind of cringe, like, surfaces. They're not difficult, they're not hard. What you can do is you can go to surfaces and we can say extrude surface. Surfaces are very similar to solids. You can see that I can pull it out a blind direction, or in this case, I want to choose a mid plane. And I want this to equal the global variable of the biggest one, which is bottom front, so BF, times 1.5. And that should get us all the way through the model. That means no matter what you change the speaker to, this plane, the surface that we're creating will always be larger than the model. Then we can hit our green check. So what we have now is a solid model, or a solid body and a surface body. We can now use the surface body to cut, but surfaces by definition have 0 thickness. So I can cut this model without removing any thickness at all. If I choose cut with surface, I have to remove a side. Instead, what I can use the tool intersect again. So using intersect, I can create an intersection between the surface body and this speaker body. This time, I want to create intersecting regions and hit intersect. Now, one thing that'll get you when using intersect for the first couple of times is the option of merge result. Even sometimes it's collapsed. You'll be like, what the heck's going on, SOLIDWORKS? Uncheck merge result, and then instead of looking exactly the same, it'll look completely different. It'll be cut in 2. Now, there is a feature inside of SOLIDWORKS that will create a lip and a groove for you. It is literally called lip groove. Now, before we go down this path, I'm going to hit save. We're going to save early, save often. It's the SOLIDWORKS motto. Speaker, save. All right, so I'm going to use the lip and groove command. Now, remember, if you don't know where it is, you can come up here and search and look like you remember where everything is all the time. Now, a lip and groove is going to require two separate bodies. Lo and behold, we now have two separate bodies. I want this component, or that solid, and that solid. I need to choose an edge to follow, and so I'm going to choose that edge right there. Now, our groove selection is going to be based on this face, and I'm going to choose my outside edge, which in this case is going to be that edge. So you can see selecting that edge will do it for me. And now on my lip selection, it's going to be on the other solid. I'm going to choose that face. And then the edge that I want to follow is going to be the outside edge right there. And then the specifications, kind of where the rubber meets the road on the lip groove command, is all of these specifications. Now, in this scenario, we're just going to let it be a 0 degrees of draft, and we're not going to put any tolerance here because I want you to see what the lip groove command does, and then we may or may not use it. So let's hit our green check, and you'll see that it's going to start to modify your model. It might even give you warnings like, hey, we're going to make this, but it's not going to be 100% right. Okay, SOLIDWORKS, show me what you got. So if you zoom in here, you're going to see that it kind of pulled it straight forward. It didn't follow the curvature of our speaker perfectly. You see these don't line up right. Now, it created the lip and groove, which is exactly what we wanted. So now our front piece can slide into our housing. But the problem is our curvature isn't right. So if we were to go 3D print this thing, these edges are going to be pretty gnarly. They're not going to line up perfectly. So you can see how they're not going to line it up. Now, unless you just want to go out there and file away or sand it away by hand, I personally don't want to have to put all that elbow grease in. Why not get it right the first time? So you can see here's our lip and our groove on our model. And again, Shift Tab will show everything, and Tab will hide everything in case you didn't know that. But because this lip and groove did create geometry, it obviously did work, but it's not working as well as we want. So what I'm going to do is I'm going to crush these lip groove features, and I'm just going to get them out of here. So we're back to these being solids. There is no lip or groove. So now what I'm going to do is I'm going to do it manually using surfacing. And I hear some of you going, oh, no, don't do that. It's going to be cool because surfacing is really fun. So don't be scared of surfaces. But what I'm going to do is take this surface body that's hidden, and I'm going to go to my surfaces command and do an offset surface. Now I want to offset this by 1/4 of an inch. That's how much overhang I want, but I want it to go back into our housing. Hit my green check. So now I have another surface offset from our first one. Then I can then use the intersect tool again, and we can use this to cut. So I can do another intersect between that surface body and the back housing, creating an intersecting region. And again, don't merge the results, otherwise you're just going to have the exact same thing whenever you come back. This is the geometry in the middle. I'm going to hide the cover and hide the housing. This is the geometry that we want to split. We want to rip it in half, and then we're going to add some to the back piece or the housing. We're going to add some to the front piece or the cover. So to do that, I'm going to also add 20 millimeter or 20, can't even think today. So 20 thousandths, not 20 millimeters, that'd be a lot. 20 thousandths of an inch of tolerance in here. So by creating a sketch on this face, I can then do an offset entities. And because this is a 1/2 inch wall, I can then offset it by 1/4 of an inch in the opposite direction, and that should be smack dab in the middle. And in fact, it is. So then we can use our surfaces and do another extruded surface, and we can do this mid-plane, and we can just have this like 1 inch thickness. So you can see that it's going through our model. And in that case, it's intersecting everything. And then we can use that tool, intersect again. This is one of the strongest tools out there. Hopefully you guys have realized that. We've used it a couple times now. We're going to create both this time, internal and intersecting. You'll see that it has two separate selectable bodies. We are not going to merge them. Hit my green check. And then to create our tolerance, this is going to be an interesting one, because if I were to hide that surface, the surfaces have 0 thickness, so I remove 0 geometry, I just cut it. But what I can do now is I can offset that surface again. So surfaces, offset surface, and instead of that face, I want to offset this entire surface body, so that one. And I can offset this by whatever our tolerance is, so 20 thousandths. Now I want to make sure it's going into, I want to remove the internal part, and I can hit my green check. You see now we have 2 separate surface bodies, so I can then hide the outside. Now, whenever you do a cut with surface, you might be cutting more than what you're anticipating. So let's not do that. Let's do a cut with surface, and let's cut this. And I can go down here and I can check that I am cutting the correct direction. And in fact, I'm not. You can see that arrowhead is pointing inward, indicating that we're going to remove all the internal geometry. I want to flip it using my arrowhead. Another thing I want to do is feature scope. I don't want it to auto select. I only want it to cut this body. So this outside body is going to stay put. So by using a surface cut or a cut with surface and choosing the correct direction and then having it, the feature scope only cut that specific body, I'm not removing anything except that little gap. So now you can see we have our 20 thousandths of tolerance all the way around our model. Now all I have to do is show the housing and show the cover, and then again use Shift Tab to bring those back. You see my curvature lines up perfectly because we literally just cut the model apart, and then we cut that chunk into halves, and now all I have to do is add it. So say I want to take this solid and that, and I'm going to add them together. So again, we're going to use the combine feature, and we're going to say, you know what, I want that solid and I want that solid. I want to add them together and hit my green check. That is now one solid. I can then hide that one and show my cover and do the exact same thing, combine, and I'm going to take that solid and combine them together. So with that said, you can now see that we have our nice, pretty, rounded speaker that has our manual lip groove here, and the curvature is perfect because we use that model with some surfacing techniques. So if you guys want to get deeper into surfacing, then what you could do is you could contact your account manager. Alan Kelly and Adam Kufelt are both on this call, so they'd be more than happy to help you guys out. Send them an email, give them a call, and you might be able to get into our surfacing class coming up. Now, talking about modeling challenges, I want to move from a single part design all the way into a very large design. So I'm going to go ahead and save this in case anybody has questions about it, but I want to step into something a little more challenging. And one thing that I see a lot of people using a lot of is weldments, and that's great. But one thing that might speed you up is to use this thing called structure systems. Now, this is a completed structure system, and you can do this with weldments, but that can be challenging. It can take a lot of time to create all of these members and do all the trimming that you have to do to create a structure such as this. So let's open this thing up, and we're going to open that structure system from scratch. So one thing I want to do is go to structure system and activate a structure. Structure systems are comprised of primary and secondary members. It is weldments on steroids. So our primary member, we're going to choose our profile, just like in weldments. And then all we have to do is specify where our members are going to follow. In this case, I want to use a point up to plane. So I'm going to go up to that plane, and I want this point and that point to go up to that plane. Now you could always say that there's a direction of extrusion if you wanted to, but we're not going to do that in this case. So go up to that plane. Hit our green check to accept those primary members. Now that I have primary members, let's do some secondary members. And there's two ways to design structure or secondary members. There's either by the plane members or by points. So I'm going to do planes, and then you select your primary members and then what planes you are going to use. So very quickly, you can add these members in here. All you have to do is choose your pierce point, and in this case, I want to line it up with the top there. Now I want a couple more members. Now really one member trimmed a couple times, so I can do a secondary member, this time using points going between that top secondary member and the bottom secondary member. So I want them to be on the edges, and then I can go to my profile and I can rotate that 90 degrees. And then I can even split it. So I can say, you know what, I want this member to be split around that member and around that member, and then I can hit my green check. Now, where the rubber really meets the road on a structure system is the trimming. So you can spend a ton of time using the trim command when using weldments, but you don't have to when you're using structure systems. So I can hit exit structure system, and this is where it's going to do simple, two-member, and complex corners. So in this case, for both my simple and my two member, I'm going to use the same trim mechanisms, but for the complex trims, I'm going to go ahead and let SOLIDWORKS figure it out. It's smarter than me. It's a computer. So I'm going to hit my green check. And it's going to do exactly what we need to do for our corner trims. You can see here that everything is nice and trimmed up. So what I need to do now to add to this structure is to actually leverage some of my other SOLIDWORKS tools like circular pattern. So I can say, you know what, I want this to spin around my center axis. But instead of clicking all of these bodies, in 2020, we now have the ability to use the structure system and pattern the entire structure, and I can get 12 of those. So that's a way that you can really drastically speed up your weldment designs. Another thing you can do is create a brand new structure system based solely on secondary members. So you can say, you know what, I want it to be between these 4 members, and I want to place it at these planes. And so now we have these members going in between. Again, choosing my pierce point so to line it up with the plane, hit my green check, and again, exit the structure system. And this time, let SOLIDWORKS just use the body trims and hit my green check. So everything is trimmed appropriately. And then what we can do is do another circular pattern that goes around the center axis, and again, pattern the structure, but this time, just that secondary member structure. So you can see very quickly, we're able to create something much more complex than just using weldments, and all the trims are perfect. Everything is exactly where it needs to be, and we didn't have to do much. We started this thing from basically 2 points. So that's a way to really speed up your weldment designs. Now, another thing that I want to talk about while we're on this webinar that I see a lot of people could really benefit from using is something called detailing mode. Now, detailing mode is actually new for 2020. So for those of you not using 2020, I recommend you get on it. But if you're using large drawings, I would recommend that you open it in a new mode called detailing mode. So I'm going to open this drawing that has over 5,000 unique parts. And it even tells you, hey, in detailing mode, these are the things that you can do. Cool, thanks SOLIDWORKS, thanks for the info. But you can see how fast this drawing opens. Now, for those of you that are using large drawings and you open a drawing, go get coffee and come back, this could really speed you up. So this is not just like quick view. This is something that you can modify the actual drawing. You can come in, you can make notes. So if you have standard notes, you could drop those notes in to the drawing. And this is the real drawing. This is not a quick view or a snapshot or anything like that. Notice how quickly we can go through all the different pages here. Now, another thing that I see people using in large assemblies is not necessarily just large drawings, but also just the assembly itself. And assemblies such as this little XYZ table here, we want to go look at this. And we're going to open up the assembly. And I opened it from the drawing using Open Assembly. And there's some tools that I see people underutilizing, and that's performance evaluation. When you click on performance evaluation, it's going to bring up information about this assembly. It tells you how many files are in it, how many documents are in the newest version, how many might have too high of an image quality, things that could negatively affect your performance. There's also this tool called assembly visualization, which I love. This is one of the things that I use on support all the time. And this really opens your eyes as to how your assembly is made up. So when you choose assembly visualization, you'll see that there's a couple columns by default. There's a quantity, which is super helpful, especially if you have 1,000 screws inside of a file. You want to know how many are in there. There's also a total number of graphics triangles, which is how dense a file is from a graphical or face perspective. So things like screws with threads, helixes, or springs, something like that might have a high total number of graphics triangles, or just something that has a very high setting on that part. Maybe you just have something that is not rebuilding very quickly, or something that's opening very slowly. We can go in and we can look at those open times and figure out which components those are. And you see in this scenario, the one that opens the slowest is this IGUS chain, which is kind of to be expected, especially because there's a lot of moving parts in there. You can also go look at the total number of graphics triangles. This one's interesting because there's only 3 of these, but it's second in the list of graphics triangles. So if we open that file, we can take a look and see what it is. And to me, that's not something that should have that high of a graphics triangle. So this is something that you might want to go down and figure out exactly why it has a high number of graphics triangles. One thing that you can do is you can go into the gear, you can go to the document properties, you can go to the image quality slider. You can see it's up here kind of in the middle. You might want to slide it down and hit OK, and that can lower the number of graphics triangles. So put that one in your back pocket so that if you have an assembly that's running a little bit slow on you, then maybe you run the performance evaluation and the assembly visualization so that you can exactly figure out what's going on and it's not just a guess. So I'm going to close this drawing as well. And the last thing I want to talk about is whenever you have complex designs at the assembly level, not necessarily at the sketch or the part level, but at the assembly level. Maybe you have some robotics and you have something that has a bunch of angles of articulation and you can't fix this model in space because it actually has to have that articulation. It has to be able to move like that. Well, if you haven't been using the Make controller for designs like this, you've been missing out. There's this thing that you can launch called the Make controller, and it has specified positions. So you can see there's a home position, there's a position over object, there's a pick up, and then there's a closed jaw, and then there is a lift. Once you lift this, now we can add more positions. We can say we want this to be position 6. We don't have to take the time to name it right now. And in this one, we're going to rotate the base and we're going to change the upper arm angle. So it's going to lift it up a little bit and I'm going to update that position. New position, position 7. And in this one, I want the forearm or the wrist angle to change. So we're going to change our wrist angle to be up and I'm going to update that position and make a new one. And on this one, I just want the gripper to open. So we're going to open that gripper and update that one. Now, a quick trick if you're going to use the Make controller is I can go back to home, make a new position, position 9. So now home and the last position are exactly the same. Now, what it does, or what SOLIDWORKS does, is it can then interpolate between all of those fixed positions to create an animation. So if you've ever used exploding for animation, it's really that easy, except way easier because it's going to collect all of your limit distance, limit angle mates, and allow you to change them on the fly. And if you have to do any kind of kinematics or motion study, you can take that Make controller and you can push it into your actual motion study. So you can import into your motion study as either key frames or motors. And you can see that down here under our mates, all of those things are captured in your motion study. So if you're having to do any type of simulation or motion simulation, you may want to heavily look into the Make controller. Well, at that point, what I want to do is I want to thank you all for attending this webinar today. Hopefully someone got something that they can put in their back pocket and use later in any type of design challenge. But I also want to open the floor for any questions. If you want to clarify anything or anything like that, Marcus and I are here to answer your questions. Thanks a lot. Thanks for attending.